like to thank all of our sponsors, especially our gold sponsor, Rapid7. Rapid7 empowers you with industry-leading security solutions and strategic expertise to stay ahead of attackers, ahead of the competition, and ready for what's next. Learn how we can help you secure the future and enter to win a Meta Quest at bit.ly/CloudSec giveaway. For those in the room, please silence your cell phones and use the mic to ask questions. For remote attendees, we will be looking for questions on Slack. Please welcome Kat Traxler.
Hey team, how's it going this afternoon? Thanks for attending. My name is Kat Traxler. I am the principal cloud security researcher at Vectra AI. I also have another side gig. I'm a SANS author. I wrote the Enterprise Cloud Security Architecture course. I'm also a frequent speaker on AWS. You might know me for my frequent talks on GCP IAM. And when I'm not doing computer things, you're more likely to find me with my hands dirty in my garden. A little bit more about my background. Like a lot of people in CloudSec, I came from a application security background. That's where I have my roots. I started my career in web app security, performing penetration testings, working within an SDLC, doing code reviews. And about 5 years ago, I transitioned to this cloud space. Initially doing offensive research in the cloud space to inform preventative, proactive controls in order to design better IAM. But these days, I am firmly on the defensive side of the house. I research vulnerabilities in the cloud, and then I use that research to design better detective controls. So what am I covering today? This presentation is more or less a debrief on a blog post I made last week. It's on a vulnerability that is really nothing more than an insufficient logging bug. And when I used to do penetration testings, these were the most mundane bugs to report on, the insufficient logging bugs. Every system had an insufficient logging finding, and it was never really clear why they mattered. But as you'll see in this presentation, when you combine that insufficient logging with feature abuse in the cloud, you can really have some far-reaching, very exciting impact. As I mentioned, and as you might intuit from the title, we're going to be diving into the replication service. And the first stop to understanding a service is you have to break down the positive use case. This always frustrates me. You can't just go right to how you break it. You have to first understand how does it work. So with that, let me introduce you to the replication service. It does exactly what you might think. It copies data from one bucket to another bucket in AWS when directed by rules. This service takes its marching orders from replication rules. You can configure rules to tell the service to copy to multiple buckets, in fact, creating multiple replicas of the same object. And those destination buckets where you're creating the replicas, they can be in different regions and they can be in different accounts. These data replication capabilities are only possible, and I'll underscore they're only possible if you've granted the service the permissions to access those buckets. To enable the replication service, you're going to configure it to assume a role, and that role has got to have permissions to access both the source and destination. No getting around that. But once you have those permissions configured, the replication service really is a delight, I might say. It's a great tool, really, to leverage to help you with your ransomware recovery strategy and your backup strategy. I'm not here to trash the service. Because like everything in the cloud, it can be used for good, or it can be weaponized for evil. And as you might imagine, the S3 replication service is a prime target for attackers. as its capabilities align with their goals. That is the exfiltration of data. I think we can all agree, just knowing a brief synopsis of the replication service, that it has some high abuse potential. If an attacker were to gain the ability to create a replication rule, they could direct the replication service to copy data to their attacker-controlled bucket, one that even resides outside of your AWS organization. As I touched on the last section here, the permissions to copy that data from a source bucket to a destination bucket, those permissions are still absolutely required. So the IAM role to replicate for the replication service needs the permissions to replicate to that external baddie account. For example, here we have an IAM policy which defined the required actions needed for replication, but it neglects to enumerate out on which resources. In this case, it's just a resource star. So this policy would be permissive enough to allow the replication service in your account the permissions to copy objects to any bucket, even those outside of your organization. Given that overly permissive policy that I just showed you, an attacker would need the ability to update replication rules, directing the replication service to copy data to an attacker-controlled bucket. No permissions are required on the objects themselves, only the ability to modify, update, create these replication rules. So in brief summary, instead of copying or moving data out of an account directly, the S3 replication service can be leveraged by an attacker to perform those same actions on their behalf. All of this is a result of a malicious replication rule. And I'll underscore, this is not a bug. This is a feature. This is working as intended. And this is one of the things I love about the cloud. This is classic feature abuse. This is not what this talk is about. I want to cover how the replication service actually writes events. Let's look at how it's talking to CloudTrail. I'm going to give you a debriefing on the behavior on CloudTrail as of yesterday, as I retested this behavior. Everybody, if you have had a moment of spacing out, now is the time to collect your thoughts and come back, because here's the actual part we care about. When data is copied by the S3 replication service, there's a get object event. It gets that object from the source bucket. Following that get object event, it then writes a single put object event in the destination account. It's that put object event where the external bucket name is revealed. What events are recorded in the source account? Nothing. There's no accompanying put object event recorded in the source account. Only as you see the initial get object in the source, followed by the put object in the destination. And since we all have our evil attacker hats on, we assume that that's an externally maliciously controlled account. So what this means in practice is that data that's copied by the replication service, there's no record in the source accounts of the external destination buckets in CloudTrail. This gap in logging allows for the copying of data without recording data plane events, like a copy object event or a put object event in the source account. Attackers can update the rules maliciously, add their external bucket, sit back, go get their coffee, and allow the replication service to do the work for them. Okay, so it sounds bad, but the preventative controls are very clear-cut, very clear-cut. As with anything in AWS, No resource policy should have stars, and that includes the IEM role, which the replication service assumes. You should be explicitly enumerating the buckets which the replication service assumes. This will constrain your replication service to only operating on specific buckets. And then you should follow that up with an SCP that, again, explicitly enumerates either the accounts or the buckets that are specifically allowed to replicate to. So given how preventable this service abuse is, and I will agree it is incredibly preventable, why are we still here talking about it? Why does it still matter to the threat hunters and defenders of the world? To know why it's such a big deal, we need to look at the defender's role in an organization and talk about how their job is to continuously ask questions and probe the environment in search of indicators of compromise. A defender's job is to detect when things go sideways, despite any preventative measures, despite any guardrail policies. A defender's bread and butter are the logs. And they're crafting detections and inspecting logs to provide that early warning signal that data might be moving. But as I showcased, if data can be copied without incurring a data plane event, defenders really can't comprehensively alert or hunt for the exfiltration of data just by looking at those copy object events or the put object events. Defenders, you need to broaden the events you look for and to monitor for the updating of replication rules. Only at that point are you going to be guaranteed to see the destination bucket. Once you see a destination bucket in an updated replication rule, then you can make a judgment call. Is that destination bad for you or not? But current state today, you will not see any data plane event logs showcasing that bucket as data is copied. So you're going to want to monitor and alert for the put bucket replication event. And it's the only place that you're going to have visibility on destination buckets is that put bucket replication. Okay, quick brief on the reporting timeline. So this part I'm going to just underscore. Way back in October, during my initial conversation with AWS, where they indicate that they don't consider the lack of logging to be a vulnerability. They referred me to CloudWatch alarming and suggested that folks can configure a CloudWatch alarm so that they are alerted whenever there's a change to a bucket replication policy. This is good advice. And I will wholeheartedly stand by this advice. However, it does not change the fact that there are no data plane logs in the source account indicating when data is moving from your account via the replication service. As you notice, the timeline for this disclosure was several months, and we never did agree that it was a vulnerability, and I do consider this communication with AWS a bit to be a failure on my part, I would say. As a security researcher, I feel like it's my job to effectively communicate impact and effectively describe the behavior that I'm seeing and why they should care about it, and I did not sufficiently do that. All right, so what did we learn today? What did we learn about a silly, dumb, insufficient logging bug whose impact is really outsized due to this combination of feature abuse? I have exactly 3 takeaways, 3 lessons to be learned. The first one, the cloud might shift underneath you. The ground might shift underneath you. So I actually tested this replication logging multiple times over the past 9 months to determine what events were showing up in the source account. The key was I wanted clues of that destination bucket, that external baddie destination bucket in my source account. Up until very recently, there was actual logging for most occurrences of the movement of data via the S3 replication service. Only up until my test yesterday did the logging completely go away. So I will be updating my blog to reflect that. I guess it's now consistent lack of logging as opposed to kind of like an irrational lack of logging. So yay. But yeah, we work in the cloud and things can change without warning. So that's fun. My next takeaway, and this is just something I think about a lot, and this bug really underscored it, was that the on behalf of, air quotes, the on behalf of problem in systems is really hard. There's just lots of problems you're going to encounter when you have proxy systems. These are systems that can be puppeted by other entities. So one of the big questions is, how do you safely delegate permissions? In AWS, there seems to be sort of they mark the transient permissions by pass role. In GCP, they mark those transient properties with act as. So there are ways to handle it, but it's a big problem on how you deal with transient proxied permissions. But another big problem is, how do you accurately record actions when they're being proxied through another entity? How do you accurately log actions when they're invoked by a chain of principals? I don't know. It's a question. And my final question, picture's not related, just liked it. Despite placing restrictions on an account, and despite placing preventative controls on principals, it's the defender's job to monitor and alert on material events. By definition, this means that all of our preventative controls have failed. Normally resilient systems sometimes have no good rotten days. So this is my call to action, that we all need to get creative about investigating AWS offerings for these abuse potentials, incorporating those possibilities of abuse potentials into our alerting, and taking into account when an attacker performs actions on objectives that they might be doing so via a proxy. And having actions on objectives via a proxy will fundamentally look different in the logs. It will be a fundamentally different type of detection. With that, I can take some questions.
Thanks so much. Sure.
Hi, thank you for the talk. I got 3 questions, so hopefully we can get to them.
3 questions?
Yeah. One,
Are you allowed to have 3 questions?
No, I'm gonna ask and see what happens. What did you notice? Like, did you have to have object level logging enabled in order to see these get object events?
Yes.
Okay.
Oh, you had data plane events.
Okay. Yeah.
Yes.
What did you observe as the caller of these get objects? Was it like the AWS Replicator service principle, or?
Yes, the replication service is a service, it's a principle. Actually, yes, the replication service is a principle. It assumes a role. The role trust policy is actually just S3.
Okay.
So, yeah.
And then when you said the logging went away when you last looked, can you expand what you mean by that, please?
Well, so up until recently, I would observe put object events, and I'll remind you, put object events are important because they reveal the destination bucket. This is what we need. We need to know where the heck it's going. I would observe the put destination buckets when only on priority rule 0 and not on priority rules 1, 2, and 3. And I could not incur a put object event when it was priority rule 1, 2, not 0, and with RTC mode enabled. It was a little esoteric. Now that sort of like partial visibility seems to be just gone, and no put object events are recorded in source accounts.
Next question. Does the S3 replication principle exist in your AWS account, where an SCP could control it, in some other AWS-controlled accounts, where the principle is not impacted by an SCP that we could put on it?
It does work. It does exist in your account. What you're going to actually want to restrict is not the principle, but the replicate permissions.
That's good to know.
Okay,
That's
yes.
not obvious. Does KMS encryption with restrictive key policies help you leak this, or like contain the leak, or show some data? Have you looked at?
Yeah, absolutely. So if you are KMS encrypting your objects, in order to set up replication, you're going to have to allow the replication service the ability to encrypt and decrypt with KMS. So step 1, that's an additional barrier to entry for an attacker to gain that additional permission. Step 2, that's actually a management plane event that will reveal the destination bucket. So you'll get an encrypt event, and that's management plane, and that encrypt event will reveal the destination bucket. So yes, thank you for that question. That was a very spot-on one.
Okay. Are you aware of other instances where there's this lack of logging in AWS when they act on your behalf?
No. Yes, there's a hand up. There's somebody who wants to take that one.
I don't know if they fixed it yet or not, but as of a year ago, generate pre-signed URL had a similar thing where there was no CloudTrail event whatsoever.
Okay.
Great data exfil method.
Okay, generate pre-signed URL. Yeah.
And then I'll just say the generate pre-signed URL is actually an entirely local operation using local credentials. So it wouldn't be possible for AWS doesn't actually see the generation of that. Yeah, once you use the URL, then that's when they would see it. So you could maybe see like reuse of a pre-signed URL might be possible. And I had one more question written down for you. You talked about like it's hard to figure out how do we do logging in this kind of case, like the general problem. But like what would a good log message look like to you that would sort of signal as a defender, like send up the flare of, oh, this is weird, I should start looking into this?
Yeah, so, I mean, step 1, we need to have the duplication of events between the source and destination accounts. Step 2, services that are used as proxies that you can puppet, they need to have, some attribute that indicates like who invoked them. And that's not always the case. It's pretty spotty. Sometimes there's, sometimes not.
Great. Seeing no more questions, thank you very much, Kat. Let's give her one final round of applause.
Thank you.